Okay, you will need to have the code loaded up that we worked on in the last video, the Bill's Burger Challenge project. In that last video, we created all the classes for a default meal order and provided methods for adding toppings and customizing a drink size. Now, I want to create a burger subclass, the Deluxe Burger, which has 2 additional toppings, so a total of 5 all up. And one other little thing, this burger, when it's part of a meal, has a single set price, meaning that the drink, the side item, and the toppings have no additional charges. Okay, now let's create this new burger. Opening the project panel, I'll create a class called Deluxe Burger. And I'm adding Extends Burger to this class. And in addition to the 3 extra attributes, I want 2 more for this burger. Item Deluxe 1, Item Deluxe 2. Now I need a constructor, so I'll create one below these fields. But I don't want to include the Deluxe attributes, so I'll just choose Select None. I now have the constructor, which just calls the burger constructor, which is all we need. Next, I want to use the IntelliJ override generation feature for 2 methods on burger. These are the add toppings and print itemized list methods. But really, I don't want to override add toppings, I want to overload it. I'm going to remove the override annotation, and I'm going to add 2 extra parameters for the extra 2 toppings, string extra 4, string extra 5. Deluxe 1 equals new item, with arguments literal string topping extra 4 and 0, and the same as the previous line but using extra 5. That sets up the last 2 toppings on the Deluxe Burger, both with a price of 0. Now let's include these in the overridden print itemized list. I want to print out these 2 new items after the original 3 on the burger class. If Deluxe 1 is not null, deluxe1.printitem. If Deluxe 2 is not null, deluxe2.printitem. Finally, I need a way to override the getExtraPrice method on burger because all toppings on a Deluxe Burger are included in the price. I'll override getExtraPrice, and then I'll just return 0 for the Deluxe Burger. And now I'm done with the Deluxe Burger. I now want to create a meal order with the Deluxe Burger. And where I want to support this new burger is in the constructor that has parameters on the meal order class. Let's go there, and I'll add a conditional check if the burger type is Deluxe. Let's do that with =ignore case, so it doesn't matter what case the user enters. If burger type .=ignore case with the argument a literal string Deluxe. This .burger equals new Deluxe Burger, passing burger type and the price of $8.50. I'll wrap the original this.burger call in an else statement. Depending on what type is passed as the first argument, I'll create the right kind of burger. If it's Deluxe, then I create a Deluxe Burger. Otherwise, it's the default burger. I've also said that if it's a Deluxe Burger meal, I'm not going to charge for drinks or side items. So I need to take care of this in 2 methods on meal order. First, the getTotalPrice method needs to exclude the side and the drink if the burger is a Deluxe Burger. Remember that we can check the type of burger using the instance of operator. If burger instance of Deluxe Burger. Return burger.getAdjustedPrice. Now if the burger is just a Deluxe Burger, I won't include the drink or side item. Next I want to change the way the drink or side is printed in the print itemized list method. I still want them to print, but I want their prices to be excluded, so again I'll use the instance of operator to change what is printed. If burger instance of Deluxe Burger, item.printitem passing drink.getName and 0. Item.printitem passing side.getName and 0 also. I'll wrap the original code in an else statement. If it's a Deluxe Burger, I still want everything printed, but I want the price to be 0, so instead of calling print item from the drink or side instance, I'm calling the static method, which the instance method calls, and passing 0 for the price. And before I can test this, I need one more method on meal order, and this is to allow a user to define up to 5 toppings. I'm just going to copy the add burger toppings method and paste a copy below it. I'll add 2 parameters, extra 4 and extra 5, and then use the instance of operator again to determine which method should get called, based on the burger type. The 2 extra parameters are string extra 4 and string extra 5. if burger instance of deluxe burger db db.addToppings, and I'll pass all 5 extras. Otherwise, I'll wrap the 3-parameter addToppings method call in an else statement. In this code, notice that I'm using the instance of operator, but this time I have a binding variable db. This lets me call the deluxe burger's overloaded version of addToppings using that binding variable, which is typed to the deluxe burger. I didn't have to cast or set up a local variable. That's pretty neat, I think you'll agree. Okay, so let's test this out in the main method by creating a meal order with a deluxe type. In this case, I want to include at least 5 toppings to test our extra fields. And I'll set the drink to small to make sure the price doesn't get adjusted. But first, I'll comment out the second meal so we can focus on the deluxe meal. Meal order deluxe meal equals new meal order with the following arguments: deluxe, 7-Up, and chili. Deluxe meal dot add burger toppings, and the 5 toppings are avocado, bacon, lettuce, cheese, and mayo. Deluxe meal dot set drink size to small. Deluxe meal dot print itemized list. And running that code, you can see the base burger is $8.50. I've added avocado, bacon, lettuce, cheese, and mayo, and the line item prices for each topping is 0. I also have a drink and a medium chili for side items, and both are included for no additional cost. The total price for the deluxe burger is the same price as the base burger, which is what I wanted. That looks good. Regardless of the toppings or the drink or side, the price did not change. It was $8.50. We've finished our first whole application. I hope you've got a lot out of these last 3 videos, and actually for these last 2 object-oriented sections of this course. Alright, so now that you've seen that solution, I just want to make a point that it's certainly not 100% perfect, but I think it's a good solution by applying the knowledge that we've learned in previous sections. In an ideal world, you'd use something like a list or an array, but I wanted to make sure I only used what has been taught to this point in the course in my challenge solution. And of course, I haven't covered lists and arrays yet. We'll be starting on arrays in the next section, actually. You'll want to revisit this challenge later, once you've learnt these. Then, armed with that new knowledge, you can look at improving your solution then. You may also notice that there's some repeated code. That also relates to using what we have learned so far in the course in the solution. Also, very importantly, keep in mind that your code can and probably will be different, and perhaps vastly different than the solution I've shown there. And that's because in programming, there's almost always many solutions to a particular challenge, and in this case, that's certainly true. I hope you did well with our challenge. Before we complete this section of the course, I'm going to talk about packages and import statements. I'll see you in the next video.